Hi everyone, week 7 summary. This week we're looking at quadratics again, but primarily we're looking at three things. We're looking at expanding quadratics, that is taking it from the form where we've got two expressions in brackets and moving it into the general form of the quadratic, ax squared plus bx plus c. We're looking at factorizing, which is the opposite of expanding. And that's taking it from the ax squared plus bx plus c form to the bracket form. And we'll look at two special cases of that. And then we're looking at solving. What am I doing? Then we're looking at solving, which is basically saying what is x when y equals 0? Or another way to think about this would be to say, what are the roots? So yeah, that's what we're dealing with today. So lay down the line. Let's have a look at one expanding. So expanding is pretty simple. Essentially, we just want to use the box method. For example, say we've got a question which is expand this one, x minus 3, 2x plus 4. So the box method is just doing this. We just take one of the terms, x minus 3, put it here, and then down the side we go 2x plus 4, and then we just go like this, and then we say, what's 2x times x? 2x squared. What's x times 4? 4 lots of x. What's 2x times negative 3? Negative 3 times 2 is negative 6 lots of x. And then negative 3 times 4 is negative 12. And then we can just write that out as this term, 2x squared. And this term, minus 6x. This term, plus 4x. Make sure you pay attention to positives and minuses, or positives and negatives, and the final term, negative 12, which gives 2x squared minus 6 plus 4 minus 2x minus 12. So that's our solution. So we expand that, and we get that. So that's all expanding is, just using the box method. And basically we're just saying we can put the factors along here, we can put one of the things in the brackets here, one of the things in the brackets here, multiply each combination individually, and then sum like terms. So in this case we had these like terms, and I'm really struggling. In this case we had these like terms, we had these x squareds, there's only one lot of that. We had these x's, there were two of them, we combined them, and then we had the 12. So that is expanding. Now we're going to have a look at factorization. And so we took it from these to the ax squared minus bx plus c general form, and now we're going back the other way. So let's have a think about this. Say we're considering, e.g., something like this, 6x squared minus 5x minus 4. So essentially I'm going to tell you two questions that you need to ask. Question 1, this will help you kind of work through it, and that is, what are the factors? What are the factors of a times c? And so, if we remember, we're ax squared plus bx plus c. So now a, in this case, is 6, and our c is negative 4. So we can say a times c equals 6 times negative 4. Therefore, a times c equals negative 24. So we can say factors are 1, 24, 2, and one of them's got to be a negative, 2, 12, 3, does 3 go into 24? Yes. 8, 4, does 4 go into 24? 6, 5, no, 6, and that's there. So, no more. So that's the first question. Ask, what are the factors of A times C? And then we ask another question, Q2, which is just, which of these factor sets, so a set would be 3 and 8, that would be one set, can be used to get B, which is in this case negative 5. So we need our B, negative 5. So we basically need, and we know that one of them is going to be negative. So we could, if we had negative 1 and 24, we'd have 23. If we had 1 and negative 24, we'd have negative 23. If we had negative 2 and 12, we'd have 10. If we had 2 and negative 12, we'd have negative 10. If we had negative 3 and 8, we'd have 5. If we had 3 and negative 8, we'd have negative 5. So that's this one. Bang. So our answer, I'll put answer here. So our answer to this one is negative 8 and 3. So they're the two questions. The two questions you need to ask yourself. Now, write out your expanded equation. So that's our general form with bx split up. So in this case we'd have, well, initially we had our 6x squared. Initially we had this one, 6x squared minus 5x minus 4. I've never done this before. We probably would have been faster to write it out, but anyway. So initially we had this, and now we can write 6, I need to get a pen, probably would be handy, 6x squared, and we had minus 8, so minus 8x plus 3 plus 3x, and this gives us our negative 5x minus 4. And now, when we look at this, what we can think is, hold on, that looks a bit familiar. This looks like something we had when we were expanding in part 1. So we'll just go back up. Look, looks pretty similar to this, I'd say. See, we've got our part B broken up into 2. And that came directly out of this box array, right? This box method. Now we've got a similar looking thing here with our B split up into 2. And so now, a sensible idea would be then put this in its box. And so we could say, well, our box is going to look like this, isn't it? It's going to look like 6x squared. We're going to have minus 8x, 3x, and negative 4. In a box drawn in a creative fashion. So this is what we've got. Now we have to, now this is the kind of tricky part, and there's no real method to this, but it's going to take a little bit of thinking and a little bit of looking. but we have to work out a number that can go here. We have to work out all the numbers around, okay? I'd say probably the 4 has quite a few factors. It's got 1 and 4 or 2 and 2. So that's probably not a good place to start. 6 has a few as well. It's got, 1 times 6 is 6, and 2 times 3 is 6. 8, similarly, 1 times 8 is 8, 2 times 4 is 8. 3, however, only has 2. It's only got a 1 and a 3. Okay? So we know that we've got to have a 1 at one of these places and a 3 at another of them. If we've got a 1 here, we've got a 3 here. If we've got a 1 here, we've got a 3 here. But we also can think, well, if we put 3 here, then we know that that 3 has to multiply with the number that's here to give a 4. And 3 doesn't really multiply with any whole numbers to give 4. It only multiplies with fractions to give 4. So we don't want our 3 there because we need a 1 and a 3. So we're going to have a 1 here. And that means we're going to have a 3 here. And because it's x squared, it's going to be a 3x. So 1 times 3x is 3x. Perfect. And that tells us now we've got 1 times the number here equals negative 4. And 1 times what equals negative 4? Well, it's got to be negative 4. Right? And now we can only have to fill in this last one. We've got negative 4 times something gives negative 8x. So that's got to be 2x. 2x times negative 4 equals negative 8x. So you can see we're working backwards. Therefore, 6x squared minus 5x minus 4 equals, just, it doesn't matter which order we do them in, but we can go 3x minus 4, 2x plus 1. So that's how we factorize. So all we have to do is say, 1, what are the factors of a times c? Rule them out. Again, remembering that because we've got a negative 24, one of them has to be a negative. Question 2, which of these factor sets can be used to get b? In this case, b was negative 5. Have a look through, just work your way down. I mean, you won't have to work your way down later on because you'll be able to see, well, those two numbers can't combine to give 5, those can't combine. Yep, okay, there's 5 difference there, so that's pretty easy. And so you've got your negative 8 and your 3 there. Then, now, write out your expanded equation, kind of like general form, with bx split up. This was our general form, and this is with bx split up. There. Then put this in its box. So just that one there, that one there, that one there, that one there. And now comes the interesting part. You have to think about it. But the key thing here, we said, was start here. Here. Numbers like 3, 5, 7, 11. Prime numbers are really good ones. Or number with least factors. And you can just work your way there. And we said, well, we know we've got a 1 and a 3 to get here. And if we had 3 here, that wouldn't work because 3 times something doesn't equal 4. And so it's going to have to be the 1 there. And then we just worked backwards and said, well, that means negative 4 has to be there. That means 2x has to be there. And so that's how we did it. So that's the standard case. But then we've got a couple of special cases. So we'll have a look at them now. And the main thing here with our special cases was simply that, well, the main thing is look out for squared numbers. Okay, so that's 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16. So these kind of things. Wow, nice bracket over. So these kinds of things. Look out for our squared numbers. For example, EG1. You might see an equation something like this. So this is remember, this is when factorizing. This is when we're going from our ax squared plus b to our bracket form. So we might see something like this: 16x squared minus 9. And whenever we see equation and it's like factorize this, we should say are any of the numbers squares or squared numbers? And in this case, both of them are, right? And so we can say, okay, well we've got 4 times x, and then we've got plus 3, and we've got 4 times x, and we've got minus 3. And we notice that in this case, we'll just do our box quickly. 4x plus 3, 4x minus 3. 4x times 4x is 16x squared. 4x times 3 is 12x. 4x times minus 3 is negative 12x. And 3 times negative 3 is negative 9. So these cancel. So 16x squared plus 12x minus 12x minus 9, boom boom, gives 16x squared minus 9 as required. So whenever we see an equation like this, a quadratic like this, with no b term and with our squared numbers, we've got this kind of thing, and we call this difference of two squares. Okay? Difference of two squares. And you can see that our squares, this is one of our squares, this is our other square, and this is the difference. We've got a positive and a negative. So that's our example 1. EG2. What about if we get something that looks like this? EG2. We could have something like 9x squared plus 36x plus 36. Something like that. And again, straight away, first thing we're thinking about when we're trying to factorize, first thing we say is, are there any squares? And we say, well, yeah, hold on, there's the 3 times 3 there, and there's a 6 times 6 there. So we're probably going to have something along the lines of 3x, and say we've got a plus 6 there. And then we say, well, we've also got this 36, so I wonder where that comes from. We don't have a positive, we don't have plus, and we don't have plus and minus as you did with the difference of two squares up above, because the b doesn't equal 0. But what about this? What about if we've got 3x plus 6 again? Chuck that in a box. See what comes out. 9x squared, 18x, 36, which gives 9x squared plus 18x plus 18x plus 36, which gives 9x squared plus 36x. It's meant to be a plus. Plus 36. So we know that we've got 3x plus 6. 3x plus 6, which we also call 3x plus 6 squared. And this is called perfect squares. And so that's kind of one of the warning signs, one of the things we can think about when we're asked to factorize. Because remember, we're still under factorization here, special cases. I guess, yeah, so always looking for those squared numbers, and if there's no b term, we may have a difference of two squares, and if there is a b term, we might have perfect squares, and that could be these could both be minuses there, and we would just have negative in there as well. One other thing to mention is if can't factorize with whole numbers, can always use quadratic formula. And if you want to have a bit more look at that, see week 6 summary. Cool. So use the quadratic. If in doubt, use the quadratic formula. Final thing to look at is solving. So solving quadratics. So, okay, 3. What do we want to say about this? Well, solving, okay. What is solving? Q, question, answer. Finding the X values for which, I'm going to do this, for which y equals 0. So say we've got graph like this, got our x and our y, and then we've got something that looks maybe something like this. And then when we say, what are our x values for when y equals 0? Well, y equals 0 all along this line, doesn't it? Y equals 0 all along this line. Let's do that in a different color. All along this line, y equals 1. But what we're really concerned with is when y equals 0. So that's what we care about. These are also called the roots. So in this case, it's going to be that point there and that point there. And so let's think of an example. And this is what we're going to use in this case. Use the Null Factor Law, right? And so this is assuming we've just factorized. Okay, so let's assume we've factorized and we've got an equation that looks like y equals 2x plus 1, 3x minus 4. So we've already factorized and we've got this one. So therefore, solutions when 0 equals 2x plus 1, 3x minus 4. And this is because finding the x values for which y equals 0. We've got y equals 0. So that's our thing here. Now the null factor law says that basically if this equals 0, right, then we've got 0 times something equals 0. Great. Or if this equals 0, then we've got something times 0, which is 0. Great. So the null factor law will say 2x plus 1 equals 0, therefore, or therefore 3x minus 4 equals 0. So what we've got is, if we just minus 1 from both sides, we've got 2x equals negative 1, divide both sides by 2, x equals negative 1 on 2 equals negative 0.5, to put it another way. And here, if we just add 4 to both sides, we've got 3x equals 4. Divide both sides by 3, and we've got x equals 4 on 3, which is the same as 1.333, because it's the same as 1 1/3. And so we've got this one could be, this point could be negative 0.50, because 0 is the y value, and this point could be 1.330. Remember, we talk about our coordinates in terms of x, y. So that's just using the null factor law. It's saying either that's the case or that's the case. Either this first term equals 0 or this second term equals 0. So that's using the null factor law to find the roots or find the solution. Cool. Relatively quick one today. Covered a fair bit of ground. Hope it was helpful.